Hi, welcome to this weekly. We will focus on factoring this weekly. Let's look at example 1. It says, if 6x squared y squared were factor out of 24x squared y cubed minus 18x cubed y squared, the binomial left would be. So let's go through our method here. The first thing we always try to look for is a GCF. Can we factor by GCF? Well, it looks like this is the GCF that they're giving us. So how do we factor by GCF? Once we have it, we divide each of the terms by GCF. And so this would be also divided by 6x squared y squared. So when we divide, let's see what's left over. Let's see, 24 divided by 6 is 4. The x squareds, they will divide out, leaving us with 1. Or in other words, they cancel. In this case, y to the first, bring down our subtraction sign. 18 minus 6. 18 divided by 6 is 3. X to the first. And the y squareds, they will divide out. And in other words, cancel. That's what's going to be left over. The way you write your answer is 6x squared y squared multiplied by that, but we were looking for 4y minus 3x. And one last thing, you can always double check by using distribution to see if your answer is correct. And this does give me 24x squared y cubed, and this does give me a negative 18x cubed y squared. Thank you, and please stay tuned for the question that follows. Okay, let's look at this next example. It says, if the area of a rectangle is expressed as x to the sixth minus 16y squared, then the product of the length and the width of the rectangle could be expressed as. So basically what we're going to do is we're going to take the area of this rectangle, it's a polynomial, and we're going to try to factor it. So let's look for a GCF. That's what we always do first. There is no GCF here. Let's see if it's a special case. It does look like it is a difference of perfect squares. It's not a perfect square trinomial because it's a binomial. I know it's a perfect square because difference of perfect squares because x to the sixth it is a perfect square. Any variable with an even exponent is a perfect square. 16 perfect square, y squared also perfect square, and we have a subtraction. So that's what we're doing here. All I need to do is remember my pattern for difference of perfect squares. The first term, the x to the sixth, that will be split up into x cubed and x cubed. All right, taking the square root of x to the sixth. We're going to have a plus and a minus. That's why there's no middle term. And this 16 is a 4 and 4. Y squared is y and y. So it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And again, if you wanted to go through double check with double distribution, we'd have x to the sixth. We would have a negative 4x cubed y, positive 4x cubed y that would cancel. And then we have a minus 16y squared. So there's our answer. Please stay tuned for the question that follows. Okay, here's another example. It says factor x to the sixth minus 6x cubed plus 9. So again, we'll always try to find a GCF first. Looking at this, there is no GCF. So we'll check to see next, is it a special case? It's not the difference of perfect squares. That's always going to be a binomial. Could it be a perfect square trinomial? Well, let's look. Do I have perfect squares on the edges? In the front, I actually do. Again, any exponent that's even, we're going to have we'll have a perfect square. And 9 is also a perfect square. And so that is the perfect square trinomial pattern. And so what we're going to have here is we're going to be looking at x to the sixth. That breaks down into x cubed and x cubed. The 9 will break down into a 3 and a 3. And unlike the difference of perfect squares, these signs will be the same. It'll be minus 3 and minus 3. And that is why we have a middle term here. That's why it doesn't cancel out and give us just a binomial. So again, I can double check here by double distributing, multiplying here. X to the sixth, a negative 3x cubed and a negative 3x cubed give me a negative 6x cubed, and negative 3 times negative 3 is positive 9. And so that is the factored form. Please stay tuned for the question that follows. Okay, here's another example. It says to factor x squared minus 5x plus 6. Always start with the GCF. There is no GCF. There is no special case here. It's not the difference of perfect squares. It's not a binomial. And it's almost a perfect square trinomial, except for the 6 is not a perfect square. So we know we have to use the AC method here. And the lead coefficient is 1. And so this is going to be the quicker of the two AC methods. So when I go through and I use the AC method, I always have to multiply A times C regardless of whether I'm going to be grouping or not. We won't be grouping here. This is the quicker of the two methods. But all I'm doing is listing out my my A, B, and C terms. And then what I would have to do is say, well, what is A times C? A times C is 6. Now, what are the two factors of 6 that add to the B term, the negative 5? Well, it's not 1 and 6. It has to be 2 and 3. And in order to make things work properly, both factors have to be negative. They would that way multiply to a negative or a positive 6, but add to a negative 5. Now, because this is the AC method with a lead coefficient of 1, all I have to do at this point is say, well, the x squared is going to give me x and x. And what were my two factors? They were negative 2 and negative 3. That is the factored form. And if you wanted to double check, again, you could distribute x squared. There's a minus 3x, a minus 2x for a negative 5x, and a positive 6. Thank you, and please stay tuned for the question to follow. All right, let's look at this next example. It says, factor the following. We have x cubed minus 4x squared minus 5x. So again, let's look for a GCF. And there is a GCF in this situation. That GCF is going to be x. And so if our GCF is x, what we do is we go through and divide by x everywhere. Remember that the x's actually have exponents, right? So exponents of 1. So when we divide out here, we're going to have x squared, a minus 4x, and a minus 5. And the x should be written in front. That is the greatest common factor. And we should always check to see if what we end up with is still factorable. So inside of here, inside of the parentheses, is that quotient factorable? There is no GCF for that, the x squared minus 4x minus 5. It's not a perfect square trinomial. It's not a special case. I'm thinking that we still can use the AC method here. Let's check here. So with A is 1, B is negative 4, and C is negative 5. Okay, so our AC is going to be negative 5. And the factors of negative 5, we only have 1 and 5. Those are the only options. They should add to negative 4, and so that means the 5 is going to be negative. All right, so since the lead coefficient is 1 here, well, that's the method we were using. We don't have to do anything other than take the x squared and break that down into x and x, and then literally write plus 1 minus 5, because those are the two terms. And don't forget, the GCF needs to hop down every step. And that is the factored form. There's nothing else we can do with this. So we are done with this question. Please stay tuned for the question to follow.